Hi everyone, welcome to this presentation on supervised modeling using k-nearest neighbor. In this video series, we will cover concepts of neighbors algorithm, detailed explanation of key considerations for KNN, comprehensive coverage on model evaluation methods, and we will also provide a detailed walkthrough of the tuning process for KNN. Let's get started. The few topics here. So we'll start with context and concepts of KNN. What is KNN? And then subsequently, we will go into all the subtopics related to KNN. Yeah, so let's spend some time understanding what is KNN and be familiar with some of the key words and jargons used in the neighbors algorithm. So the objective of KNN is essentially to perform supervised modeling. So by meaning of supervised modeling, we are referring to the data set which has features and also the labels. In order to predict the label or a value of a new data point, we use supervised modeling, and KNN is one such algorithm. Is based on the labels and the values of the k nearest neighbor in the training set. We will talk about what is nearest neighbor and what is k. To assign the most likely class or value to a data point or test point by considering the classes, that means if you have considered three neighbors as a deciding criteria, then out of the three neighbors, we will look at the majority class, and the majority class is going to be the prediction for the test point. Similarly, if it is for regression, then we will look at the neighbors and we will average the values of the neighbors or the labels of the neighbors. And once you average, that becomes the prediction of the test point. So the algorithm operates on the assumption that the data points which are similar or with similar columns or similar values in their features are likely to have be together, and they will produce the similar outcome. So what is a neighbor? If you take a simple example, let's say there are two customers, and these customers are defined by various attributes like personal information, demographics, purchase behavior, preferences, interactions, loyalty, feedback, and so on and so forth. Now, depending on these variables, you might choose to assess the similarity between the customers. So, if they come closer based on the similarity measure, for example, Euclidean or any other measure, then we call these two customers as neighbors. So they become neighbors based on the attributes that you have. Let's take another example here, defining nearest neighbor. So let's say these are the people and the rating of the people is given like 1, 2, 3, 4, 5, 6, 7, 8, like this. If you notice, the rating is between on a scale of 1 to 10, and the rating difference between the a pair of people is differing by 1 unit. Any person is similar to the person on the left or right because the distance is same. For example, Roy here, the rating is 6, and the person on the left dash has a rating of 5, so difference of 1. Similarly, Izaz here on the right hand side, and the difference is 1. So that means they are equally similar to Roy. But Roy's similarity with the Winnie is not same because she is about 2 units away. So similarity here in this case is mathematical notion of a distance, which is simply 1 unit. So all persons are neighbors. In effect, what we're saying is entire, the entire domain is, neighbors, but some of them are nearest to a particular one. So that's the idea of nearest neighbor. So let's talk about some jargons that we use in KNN. So neighbors refers to another user who has similar movie preferences. So in case of dataset, one row versus the other row, and if the distance between the two rows, those two rows is very less or the least, then we call those two rows as neighbors. Another acronym that we use for neighbor is distance. That means the distance measures the similarity or dissimilarity between two data points. One more term that we use is proximity, which is similar to the distance. So proximity means how near is the test point to some of the other points in the data set. So all these four terms are essentially the same that we use in the neighbors algorithm. Let's look at another example here, bunch of birds, and these birds are tagged with a label A. Some birds are tagged with label B, and some are tagged with label C. And for example, let's say each of the bird can be represented by these columns. And these columns have some specification like wing length, body length, weight, shape, and size. So you can define each of the bird in terms of the values here. Now let's say we have a test bird and you want to know whether the test bird belongs to the type A, B, or C. And the specification for the test bird is also given here. So need to predict the class of this test bird. So what we need to do here is to take the test bird and compare against all the birds that we have in our sample one by one. So and then when we compare, we essentially mean to find out the distance of the test bird from sample 1, sample 2, sample 3, sample 4, and so on and so forth. And out of all the distances, we will pick the minimum or the closest one. Let's say this is the closest one. That means the test bird is similar to sample 2 that you have here. So whatever the type assigned to sample 2 would also be assigned to the test bird. So how do we predict class of a test bird? There are many approaches here. So one approach would be to look at the test bird and the very close or very similar only one neighbor in your training sample. Other approach can be look at multiple neighbors or multiple similar birds in your training sample, and then from the multiple pool we will find out the maximum or the type of bird which is more or most prominent in that pool. So the option 1 will look for the training bird which is most close to the test bird, which is yellow in this case here. And here is another option, the test bird, and then you have one very close which is yellow, but blue is 4 of them. So in this case we are considering 5 neighbors. And among the 5, 4 is the majority blue. So we will say the test bird is of the type blue. Now, how to determine, how many that we want to compare against? That means the number of neighbors. That's the tunable parameter for every data set. So let's take an example here, the bird sample, beak length and the voice pitch, and the bird type is sparrow, robin, and crow. And these are the specifications. And let's say we have a new bird with a beak length 4.5 and the voice pitch 6.0. And based on the training sample, you want to find out what is the type of the bird with the beak length 4.5 and the voice pitch 6.0. So we can consider, let's say, number of neighbors equals to 3. Now we are going to compute the distance of the test bird from the training birds using Euclidean measure, and you have the distances here. And you notice here the least distance is the top 3 are the very close samples to the test bird. So the decision would be based on the top 3 or closest bird. In this case, sparrow 2, robin 1, and sparrow 1. And then we make a majority criteria as the prediction method. So the bird type of the neighbors are sparrow, robin, and sparrow. So there is 2 instances of sparrow and 1 instance of robin. So the classification would be of, for the test bird, it will be sparrow, because sparrow appears twice in the neighbor, and we consider the neighbor world to be consisting of 3 closest birds. So the takeaway that we have is k equals to either 1, or you can set k is equal to some number after experimentation. Let's take a look at some intuitive examples of KNN using Python code, and then we will also implement the KNN using breast cancer dataset. Let's take a look at the example of simple neighbors algorithm. The name of the package that we use is nearest neighbor, and this is actually a package which has a classifier. Is not exactly a classifier, but in the next example, I will be showing you how to use the classifier. Now, this is simply returning you all the neighbors. Let's say you have a data set with a sample, and for that sample, you want to find out what are my neighbors or the closed samples. For that, we use this particular package, which gives nearest neighbor. Let's generate some dummy data here. These are just the dummy data. And we can ask for 5 neighbors for any test point, let's say 0.6 and 0.6. And let's execute. So he's saying the label is query for query point, whatever query point that we have given, the label predicted is 0. And why so? If you look at this here, the 3 numbers are red and 2 are green. And the red means it's class of 0, green means class of 1. So 0 is in majority, and that's the prediction. Let's go ahead and change this to number of neighbors equals to 3. And now you will notice some change here. Now the prediction is essentially 1, because the number of neighbors within the the set criteria that we have is 2 are green and 1 is yellow red, and red belongs to class of 0 and the green belongs to class of 1. So the majority is the determinant of the predicted class. So in the next example, I'll be showing you, let's look at one more case. Let's make it 7 neighbors. And if you notice, here the label prediction is 1 again. So this cannot be simply a random choice as to what the number of neighbor can be, but rather is a more diligent process that we have to follow and come to a conclusion as to what the number of neighbor should be. So that was a quick demo on KNN intuitions. In the next video series, I'll be talking about how to apply KNN on breast cancer dataset, and then we will also subsequently talk about all the subtopics related to KNN. For example, optimal value of K. How do we determine the optimal value of K? See you in the next lecture. Thank you for watching.